started. Hopefully this will not take too long. And it looks like everything is good to go. Mute the volume a bit. Yep. Okay. So, this is the second video for how to do OpenGL with SDL and SDL2 and C++. As you guys probably remember last time, we went over just the basic setup of everything. And so for today's tutorial, I want to go over how do you actually create a window. Now, last time we had this simple little sample application. And again, just let me know if anything's lagging, and I'll go through and I'll update the stream. But so far, it looks okay. So with this, last time we went through and did this, we ended up having it just do a basic output. It wasn't anything too crazy. It was just displaying some shapes and stuff, and that was about it. So this time around, what I want to do is I want to go through and show how to create a window class and some other stuff, and then we're going to go through and basically just get the window showing up, and then go from there. So let's go ahead and we'll jump right in. So to start things off, I want to explain how we're going to structure this. And I also want to explain why we're doing the window stuff with OpenGL, or with SDL, and what exactly that means and how that's all going to work. So if you guys remember, the last time I did this, we talked about how there's several parts to OpenGL, and really OpenGL is just the rendering API. And when I say rendering API, I really do mean all it does is render 3D geometry. That's about it. It doesn't handle things like creating the window for us. It doesn't handle controls. It doesn't handle sound. Its entire purpose is solely to go through and create 3D renderings. So we actually need a way to go through and create a window. And if you look at this code that I showed before that we just got online, if you come down, it actually has to create the window here, and it also has to create a renderer. And to basically explain what a renderer is, it basically holds whatever OpenGL draws. So there's a couple parts to making our window and getting it ready for OpenGL. The first part is to actually create, or to initialize SDL. And this involves this whole video command here. And then we actually have to go through and create a window and tell it some basic properties such as, the size, what type of window it is, and all sorts of other little things. And then once we do that, then we actually have to create a renderer for the window. And that renderer is what is going to allow us to display OpenGL into the window. So the hierarchy of things is we initialize SDL so that we have SDL's functions available to us. Once we do that, we create a window, and that window is what we will use to actually display things in. But then we need to create a renderer within the window, and what that does is allow us to display OpenGL specifically rather than things that are specific to that operating system. In Windows case, maybe it would be a menu bar. The other thing I also want to do with this is I really want to focus on some of the new C++ 11 stuff, and I really want to focus on one big thing that I haven't seen a whole lot of, which is handling of exceptions. And this is basically to say that should we encounter an error, we want to basically go through and display those errors, making sure I'm on the right channel. So I see, okay, so we have viewers. I'm making sure real quick that I'm on the IRC version of Twitch's stuff, and it looks like that's all set. Go ahead and do a test message here to make sure it shows up, and we're all set. Cool. So continuing on, so the basic summary, we need to initialize all of the SDL functions, we need to create a window, and we need to create a renderer for that window. That renderer is where all of our OpenGL will be drawn to, it's where our main displays will happen, and some other stuff. And we're going to go over more of this in detail. So let's go ahead and get started. The first thing that I am going to do is I am actually going to remove all of this except for our main function, which we'll leave as is. And we're also going to just do that, because that's how I like to style my code. And so there's all of that. Now, if you remember from last year's episodes, the way that we generally did this is we had a game state class which kind of managed the window for us. It did all the heavy lifting, and we just kind of wrote the game code within there. This year, I really want to focus on doing this piece by piece. So the first thing we're actually going to do is we're not actually going to do a game state. We're actually going to step a few steps up, and we're not even going to do the window class yet. We're going to start with an application class. And what this application class will do is it will manage the basic things like our game state, our window, and some other little things that we'll need here and there like sound and controls. So what we're going to do is we're going to come over here, and I'm actually going to go ahead and remove everything from here except for our return 0. Return 0 is going to indicate to our application that it has run successfully. So we're going to come over here, we're going to do add new item, and we're going to do application as the first header. And this is, whoops, says it already exists. Oh, this is from when I wanted to make sure this year that when I did everything that I actually tried it all out beforehand, and so I went ahead and already did this. So we're going to go through and create this. Kind of ironic that me going ahead and doing this to make sure it works is what slowed this down. Anyways, so the first thing we need to do is we need to create a class application. And this is, like I said, going to be where our main application happens. So we need some public methods, the first of which is the application initializer. This is basically called when you create a new instance of the application. We also want to do the same thing on its destruction. Now there's a few other things that we're going to want to do. So all of the initialization is going to happen in here, and all of the deconstruction and deinitialization is going to happen here. So what this means is in here we're going to do our very, very bare bones requirements, which will be creating the window, initializing the SDL, and creating the renderer. Outside of that, everything else should happen in the game state, because those things should actually remain the same throughout the application. Anytime our game is running, from the beginning that it starts running to the end, it will always have a window, a renderer, and some other basic stuff. And that's because the game never gets rid of it. Now, you could, of course, adapt this so that your windows and stuff could have things that come in and out. You might want to render at one point, and maybe you just want to display something else at another point. But for a game, we're not going to worry about that. Everything should be happening in OpenGL in this case. So what we actually also want is we're going to want a method run, which will return a Boolean. Basically, while the application is running, we always want this to return true, but once we stop, that's when it's going to return false, and our application will then end. So we're going to go ahead and we're going to do that. Then what we are going to do is we're also going to have a method stop. What this does is it allows our application to be stopped at any point. Now there's a few other things that we're going to do. We're also going to come here and we're going to have a couple of private variables, the first of which is just going to be a Boolean indicating whether this is active or not. So basically when we call the stop method, this is going to set active to false, and then run will actually be able to detect, hey, we're no longer active, we're not running, we should stop. So that's one of the first big things. The final big thing that we're going to do, and I didn't test this beforehand, but this should all be correct, which is we're going to create a static, what's called, oh wow, I'm totally forgetting the title of that right now. It's a static instance of this within the class, which is called, wow, this is really embarrassing that I'm forgetting this. It's not a nested class. You'll see in a sec. Sorry, this is driving me nuts now that I can't remember. It's a design pattern. Singleton. Singleton pattern. Sorry about that. So yes, the singleton design pattern. So the idea of a singleton is that you're only ever going to have one instance of that class, therefore you're only going to ever need one instance of it. Now you'll notice right now that we have these as public. That is generally how you would do that class. The difference is that you actually don't want this to be public in this case. We actually want it to be part of the default view of it. And what we're then going to do is here we're actually going to have a here we're going to have a static application instance, which is our instance. We're going to do this application instance. So this is based off the singleton pattern, and what we're going to then do here is we're going to have this static application instance. And what this is actually going to do, and we'll define this later, but this is actually going to return the instance of that class. And it's pretty straightforward, it's nothing too crazy. But it basically is just going to create our static instance of the class and then go through from there. Because again, we only ever want one instance of this. This is really for our own safety, so that we don't ever have two or more happening. So we've got these basic methods. Well, what we're going to do is we're going to come over here, do add, new item, source. This is going to be application for the C++ file. Now what I'm going to do is I'm actually going to split this up into two views. So on the left side we see our C++ class, and on the right side we see our header file. So now we can actually go through and include our thing here. So it's going to be application.h, and now we're going to start building our functionality. So we have application for our first instance, and we're just going to leave that blank for now. We're going to go into that in a sec. And application. That was going to drive me insane if I didn't remember. Again, we're just going to leave that blank, and then in between we're going to have application run, which again this returns a boolean. So we're going to do bool, and we're going to just return this active. And then finally we have void application stop, and all this does is set active to false. And finally, what we're going to declare at the top is our static method, static application instance. We need to actually have that, and we're going to first check if this instance check if it's a null pointer. So this is something else that's relatively new. This is specifically for checking for null pointers. Then we have, actually what we'll do to make this more clear, application instance. So this is how you would access it statically. If you push Control Space after that colon, you'll be able to see all of the variables, and then you can access it that way. And this is going to be equal to new application, and then we're going to return application instance. And that is how we will get our instance over in here. So now if we come here, we can do, so now what we need to do is include that. We're going to get rid of those, we're going to get rid of that. Include application instance run. So while application instance run. And that is all that will be in our main method for the time being. Very, very short, sweet, and to the point, and this is going to handle everything from the creation of our application to the deconstruction of it, and so on and so forth. It's a very, very simplistic method. Nothing else needed. If we go ahead and we run this right now, all it's going to do is start up. We have one error. Private static resolved external symbol. That should have been working. I probably goofed somewhere in here. Double check. probably needs to be declared within that, now that I'm thinking about it. So we need to come in here and do that. There we go. Oh, okay, or error out. Unresolved symbol, private static class. Instance, unresolved, one external static application. That should be working. Instance. Maybe I can't have this. Or not. What is going on here? That should be the issue now. Let's Google this. What did I do? Do I need to have... It says I need to have this for some reason. Front of it. That does not seem right. Seem right. Resolved external symbol. Does it need to be done like that? Let's try this then. There we go. Always forget that. Anyways, so there's that running successfully. Sorry about that delay, guys. Long day. Okay, so the reason this is needed, and I always forget about this, because this is declared static here, it's never initialized, so we actually kind of have to initialize this like we would a method, like down here. So this is basically for safety checks. To make sure that it is not actually null. We could, of course, technically leave that out, and it would be acceptable as well, but I don't particularly like that. So it's just a little weird. And really, actually, we can go ahead and we can do that. So we'll set that to null pointer, and everything will run as expected. And you can see now that this is all running like we planned for, it just kind of sits there in an infinite loop because, again, we're never setting active to false. So what we're going to go ahead and do now is we're going to start adding in the SDL sections. The first thing, however, is I actually want to make this a little bit more complex, and we're going to add in what are called exceptions. Now, you probably heard me mentioning this before. Exceptions are basically when the program does something that is not right, it will throw an exception, and you can then either catch that exception and handle it. So, as an example, maybe some character ends up further off the screen than you anticipated. They end up outside of the bounds of where they should be. Well, technically, you could actually detect that and throw an exception and then move it back in the bounds. Now, that's not a good thing to do for that example. That's actually not a good way to do it. A better example in this case because we can handle it. We can actually give feedback to the user as to what's going on, and then that actually can be helpful for debugging. If you've ever gotten error messages on a program before, sometimes those can be a result of an exception being handled and saying, hey, this is messing up, you want to handle this. In this case, what we're going to do is we're going to handle a few different things. So the first thing, if you remember, is we had the SDL init function. This can throw errors sometimes. So what we're going to do is we're going to add an application exception, since that's where that's going to be handled, that will be able to handle it. So what we're going to do is we're going to create an application exception. This is formatted in the same way as C++'s runtime, C++'s exception calls. So we need to actually go ahead and include exception from the C++ standard libraries. And then what we're going to do is we're going to throw a public, that's a very important instance, of the runtime exception, or runtime error. And it should be right in there. So let me go ahead and bring up this for help. So we have that, and we also are going to want to include, now that I think about it, IOStream, because we're also going to want to output that to the user. And then we're going to take that as a runtime error. And basically all this class is going to do is it's going to have a public method that is just going to have a constructor, and it takes in a constant string called error, and it also passes this to the runtime error method. And that is actually it for what is going to be going on in this class. It's a very, very straightforward class. There's not a whole lot of stuff going on here, but there is a lot that this will be helpful for. We can tell now that this is an application error rather than some, or application exception rather than some other random thing, and we can handle it accordingly, and we also have an error message that we can fill out to make more specific. So going back over here, when we have our instance, most of this can actually be ignored at this point. We really want to focus on these four methods here. So what we're going to do is in here, we're going to try and initialize SDL. So what we're going to do is we're going to say SDL init, and we also have to not forget to include SDL in here. So we're going to do include SDL2 SDL.h. So now if we come over here, we can do SDL init, and this is where we're actually going to, for now, just do everything. And we want to make sure that, and we want to check if that's not 0. If that is not 0, that is where we're going to throw our application exception. And the error that is going to be passed from that is going to be SDL get error, which will basically get whatever error was caused when it tried to initialize. And then we're going to continue on from there in just a bit. However, we've thrown the exception. We tried to do this. It threw an exception. We now need to catch that exception. So we're going to now do catch application exception. And the reason that I did application exception rather than like runtime error, for example, or exception, which is the base class that all of this extends from, is that we want to detect specifically an application error. And what we're going to do here is we're going to print out that error to the user. We're going to say this was an application error, and then we're going to do exception dot what. And this is basically going to tell the user what the exception was. And we're going to print out a new line. And so that will give a very distinct error to the user. Now you could actually go further with this, and you could actually say what line number. So we could do line. Now this is, I'm going to show you why we're doing this and some other stuff. So we're going to actually separate that out so you can see that a little bit better, but also so we can do this. So if you remember from the last video, I mentioned that if we go up here, we go to C++ and go to preprocessor definitions. We had to add in that glue static, but we had some other stuff. We had this debug variable here. And if you notice, if we're in debug, we have that variable. If we go to release, we actually have a no debug variable. This is actually really, really useful because what we can do is we can actually give more specific errors when debugging. So when we're debugging stuff, we can do a debug build, send it to our testers, and then when our testers get an error, it's a very, very specific error code that says this line right here, like right there, is what caused this. So what we can actually do now is we can say if define, okay, if define the variable debug, okay, then we're going to want to print out more info. We're going to do std cout, and in this case, we're going to print out the line number, and we're going to say this is, what line is this? So if you look right down here, you can actually see the line number that you're on. So we go up, 31, go down, 32. Line, in this case, the error that was thrown was at line 20. So we're going to put 20. And now we have a little bit more of a specific exception, but we could even go further than that. However, we won't. Actually, we will do one more thing. We will say that this is an application.c++, because that is where the error was thrown. So now, if we go ahead and we do something like, I'm going to add in a -5 there, this is actually going to throw an exception. Or just work out fine. Maybe this has no... Thought this would do something breaking. What about SDL? Maybe that'll do something. Maybe it's a good thing if I can't break it. Well, you get the point though. If something ever happens with this, we'll be able to see a very specific error with exactly what line it's on. And we'll be able to show this more later. For this particular example, I am not going to worry about it that much. Try and remove that. And again, this will only happen if we're in debug mode. If we go to release mode, it won't happen. If we go to debug mode, it will. Let me just double check one thing real quick, because I can't remember. I thought it had to be _debug. I guess not. I thought it did, though. That seems to be working a little better, though. But anyways, we're going to use _debug to be safe. Yeah, that's why. See, when it's, this is what I was worried about. I don't know why it auto-generated for debug like that. But basically, if we go up to here, you'll see that debug is got an underscore in front of it. So if you're actively in debug mode, this line will look like normal. But if we go to release mode, you'll see that it will be kind of grayed out there. So we're not going to worry about the differences between debug mode and release mode right now. We're going to kind of save that for later on. But now that we've got this all set, we actually need to start going in now and creating our window and such. So now we're going to come over to here. We're going to do add, and I'm going to move this over. We're going to have all our C++ files on the left and all our header files on the right. So we're going to create a new header file, and this one is going to be called window. So we've got our application running, we've got SDL initialized, now we can go through and start creating our window. So we actually want to create a window class. This is going to kind of simplify everything. We need to include a few things. We need to include SDL again. And you'll notice that I keep adding in a normal / for this. That's just because of it's a little finicky about some of that stuff in Visual Studio. So we also need to include IOStream. And again, we're going to include the exception handling. Now, if you guys want to read more on exceptions, there's a great link that I have. Let me find that real quick for you guys. And it's from, here we are. So this is a fantastic link from cplus.com. It kind of goes over exceptions, but the big thing I like is that it shows some of the other exceptions. Now you'll notice we're actually using a runtime error exception because this is an error that is specifically detected at runtime. In this case, it's caused by another library, so we're creating a custom exception to also be able to detect more specifically where it is. And there are other ways you could do this. Oops, sorry, I have a knock at my door. Oh, right. Sorry about that, guys. Girl Scout cookies for sale, and I went out there and decided to get a box real quick. So, alright, let's jump back into this. I apologize for that. So, as you can see, we've created our window. This is a very, very straightforward basic system. So we have our exceptions and stuff that we're handling in here as well. So we actually are going to go through, and I'm just actually going to keep this nice and simple and copy from here. So what we can actually do, if we really want to get fancy, is we could technically inherit this from application. I don't really see much of a point in that. You know, these are really all going to be the same in this case. But you know what? Let's go ahead and we'll do it. So actually, we're not going to do that. So this one is not going to be an application instance exception. It is actually going to be a window exception. And we can just copy that there. And we have our basic window exception. So now we're going to go through and create our window class. So the window class is going to have a few basic things. It's going to have some public stuff. It's going to have some private stuff. Now, with the application, we only ever want one instance of the application. That's why we ended up doing the singleton pattern. Really happy I remember that properly now. So that's why we ended up using the singleton pattern for the application. But with our window, we might actually want multiple windows. This is actually a really, really cool thing that you can do, is you can have multiple windows with a single application associated with it. This is great if you want to do things like debug your game and have a nice, pretty debug window on one side and your game on the other. So what we're going to do is we're actually going to handle this like a normal class, and then it's actually going to be created within our within our application class. So what we need to do first is we need to create a few different things for handling this. The first of which is we need our constructors. Now, to go through, and let me bring up the documentation for the window creation method real quick, just so you guys can see that. So let me go ahead and get that link. And the reason I'm doing this is so that you guys can see what exactly this class is for. So if we bring this up, you can see that there's a couple things this takes in. The first thing it does, that we'll notice, is that it returns a pointer to a new window instance. Now, You guys are probably wondering why we're going to be creating a window using this whole way of doing so, and that's because when we're done with our window, we actually have to call a manual destroy method. Normally in C++, we could use something like shared pointers or some of those fancy things that kind of automatically clean up our memory and stuff. However, that's really, really C++ focused. And in this case, this is actually maintaining backwards compatibility. So we actually don't want to do that. Let me bring up shared pointers right here. And we'll be going over these a little bit further. I do not like that site. Here we go, shared pointer. So shared pointers, they automatically go through and manage everything. Is deleted normally by calling the delete method and other stuff. But this is not really the best way, in my opinion, to handle it. What we're going to do is we're going to instead focus on using this with a more of a C-like interface, just to kind of match up with how SDL is doing it. So continuing on from there, the basic parameters that go into this are very straightforward except for flags, and we're going to go over that more in depth later on when we actually start making the game. I'm going to cover it briefly now as well, though. So the first thing is title. This is that little title that appears up here in your window. You know, up here you can see it like that. Up here you can see that's the title. This window is Microsoft Visual Studio Demo Project. So that's actually what title controls, is whatever that says. X and Y are the starting positions of the window on the screen, so as soon as it comes up. And you can actually use these variables here or here to create it as well. So you can either provide an X position, you can provide SDL Windows position centered, which centers it in the screen, or you can do undefined, which we're not going to worry about. And then you have the width and height of the window. This lets you control how big or small it is, and then flags. So this, if we go over here, and again, I'll post these links in the video description. If you want them and you're on the IRC channel, just go ahead and let me know and I'll post them there. But this is basically all the different flags you can pass to that last version. So there's a couple of them. The first thing is window full screen. What this does is it puts it into full screen. But the big difference between this and full screen desktop is that this one uses whatever sized window you pass in. So if you say that the window is 640 by 480, and then you pull it up and it full screens on a 1080p monitor, which is HD, it's actually not going to be an HD resolution. It's going to shrink it down to whatever resolution is there. So that's really cool if you want to maybe, I don't know, have that for some reason, or if you're testing it in a specific resolution at full screen, you can do that. Without changing your monitor's resolution each time. But this is the one that we're going to probably use most of the time, which is a full screen desktop window. Now the other thing that you'll see is we have SDL window OpenGL, and this is part of it as well. This basically adds in OpenGL support. Then we have a window shown, which shows the window, or hidden. We can do a borderless window, which is really cool because you can basically do a full screen window without borders, which, again, we're going to go over that a little bit as well further down the line. Resizable, to let it be resized, minimized, or maximized immediately after. Whether this window has input focus, and this basically determines whether or not it should be the focus one. This is the same thing, but not necessarily grabbed, I guess. I'm not entirely sure what that is. I have not seen that before. Mouse focus, so you can click on it and stuff, so like where your mouse moves and stuff is focused there. This is useful for games that want to focus your cursor on the game rather than having it be able to move outside the boundaries of the window. This is a window not created by SDL. I'm not sure why you'd want that. Window allow high DPI, so that's for basically that's a mode that your monitor and stuff can enter. And then this is also with mouse input capture, similar to mouse focus, but not really. We're not going to worry about most of this. So and the one thing to notice as well is that you can use one or more of those flags, but they have to be ORed together. So it would be that, ORed with that, ORed with maybe several things. And we'll show that in just a sec, because there's actually a few of those that we are going to want. So to kind of start this out, what we need to do is we need to have our window class there. Oops. And then we need our window deconstructor as well. And then for our private variables, there's two. There's one we want right now. We're going to go over the rest of it later. But the first thing that we're really going to want is this SDL window pointer. And what this allows for is this allows for us to access the SDL window that we're going to be creating later. So let's go ahead and we'll go start that up. So we're going to do SDL new, C++, and this one is going to be window. And again, we'll move this over here so we have this all put up in that way so we can easily see what we're writing the code for. We're going to include window.h, and then we're going to come down here and we are going to have window, and we're going to do the same thing for our deconstructor. So now that we have that, for our window, what we're going to want to do is we're going to want to try and create it. So we're going to do that is equal to SDL create window. Excuse me. And this is the other thing I forgot. I knew I was forgetting something. We actually want to also pass in some parameters. So we want to do a few things. The first is we want to have a constant string that is going to be passed in for the title. We want our x position, our y position, width, height, and we're going to leave the flags alone for right now. We can do this later, but I'm not going to worry about that. So we need these parameters passed into this method over here. And now what we need to do is we need to create this window. Now the SDL creation of this window expects that the input for this is actually not a string object, but a character array. So we want to have this be C string, which basically converts it to a character array, as you can see there. We have x, y, width, height, and then for the flags right now, we're just going to do window shown. And the other thing that we're going to do, so this is our first variation of the window, but we're also going to add another one. We're going to overload the constructor so that we can have it with width, height. And what this version is going to do is basically the same thing, but it's going to do a centered version of the window on the screen. So if we come through and we do that, now we can go through. And remember how before how I said that there was a SDL window position centered? So what we're going to do is just use that for each x and y. And that will kind of make it an easier method. Generally, when the game starts, you want it to be centered on the screen. Now, the big thing that we have to do is we actually now have to check for errors. So what we're going to do is we're going to say if this SDL window equals null pointer again, basically checking that it's not null. We're going to throw a window exception, which is then going to do SDL get error. Otherwise, we're going to do some other stuff in a little bit. And we're going to do this exact same thing here. So basically, that's going to try and create our window. If it succeeds, then the window will be created, and we're all happy, ready to go. Otherwise, it will error out. Now, the final thing that we also want to do is we want to come down here, and when the window is destroyed, we have to make sure we have to destroy the window for the SDL object. So we want to do SDL window destroyed. So that will make sure that when our window object is done, it destroys itself. So now, if we come over to our application.c++, let's go ahead and add in the window creation. So we need to make our window object here. We also need to include that in. So we can actually get rid of these because those headers are included in our window header here via these. So that'll kind of clean up some of that code. Now what we want to do is we want to add our window object here. We're going to do a pointer to it because, again, we want to make sure that we clean that up properly and stuff. Though I guess we could do a shared pointer there. I'm not going to worry about it. It's all set up to be automatically cleaned up at the end anyways. So we might revisit this later and redo parts of it, but for right now this should be it. And the reason we'd revisit it is not because this is incorrect, but because there's going to be some more stuff that we're going to want to add, especially for the virtual reality side of these. We're going to want to do some things like addressing direct mode and stuff, but for right now this is all good. So we create our window there, and remember how I said before that if our application successfully goes, we're going to want to do some other stuff. That's part of this. So now what we want to do is create our window. It's equal to new window, and we're just going to name this, in this case, test, with a width of 640 and a height of 480. We're going to do actually demo project, since that was what we titled it. Now remember that this window can actually throw the exception here of a window exception. So we need to make sure we handle that over here in our application. And this is pretty easy. All we do is we do catch window exception, exception. We're going to handle it in a similar manner as we did there by saying window exception or window error. And this is going to be occurring because of where it could happen. It's going to be occurring right here on line 5 of window.c++. So line 5 in window.c++. And so that's a very specific error again when debugging that we can see, okay, that's where error happened. So there's all of that, and then obviously when this is all cleaned up, that will automatically clean up the window as well. The one other thing we have to make sure we do here, and I completely forgot about this, is we have to make sure that we call SDL quit. And this is basically going to clean up everything in the end. So SDL quit, run, and there is our quick little window. Now you'll notice that the window, there's not anything we can do. That's because there are events building up. So to explain basically what an event is, whenever your application is running, there are events like key presses, other things that are need to be handled. So we actually have to go through and check. First off, make sure that this whole application is active, and then we have to create a temporary event here called event. And what we're going to do is we're going to go through and we're going to pull for all of the events going on. So it's going to go through and iterate through. And what we're going to do is switch out the event type. And the big one that we're going to handle right now, if event type SDL quit. Oops, totally messed up. Case SDL quit. Then we're going to do this stop. And we're not going to worry about the other events for right now, but we're just going to handle that. And what that's going to do now is if we run this, you'll notice that we can move it around. It doesn't have our swirly mouse anymore. If we click exit here, boom, all done. And you'll notice that there were no errors that happened. It's all very straightforward. Now, so the big thing you'll notice is that if some kind of exception happened there, which we're not really worrying about, but if an exception happened there and we wanted to detect that, neither of these have to worry about that, but the window closes. And this is going to tie back in later, but the big thing that you might want to do, because again, when we finish this application, when our game is completed, we won't have this giant console window. So any exceptions that occur, we won't actually be able to have the user see. Really, what we actually want to do is we want to have this in a log file. And this is where one of the nice things about C++ comes in, is that if we look over here in our application, we have all these std couts. And we're going to be going over this later when we start doing our error handling and things and actually getting the game polished up and ready to present. That's kind of a step in and of its own. But what we'll be able to do is redirect all that output from our standard stuff into an actual log file. That way when the user's has an error or something happens, the game breaks, we can just be like, okay, send us your log file, we'll look through it. And that will go through and output everything. So right now this is all fine though. You can see this all works fine, and if we come up here, and I believe that if we go to window, and I think if we do something like that, it should hopefully give us a nice pretty error. or that could be perfectly valid. Whoops. Alright. Alright, sorry about that, guys. That apparently is a perfectly valid command that probably just kind of broke everything. Okay. Let me make sure the stream is okay, which it looks like it is. Okay, cool. So, let's try that again. Let's try a negative number and see if that breaks it. Or it could just not break it at all. Okay, so that did not work as I expected it to. So we'll have to wait one more time to see an exception. Okay, so we've got our window all set up. We've got our window created. I'm not going to worry too much about that anymore. There are ways you could break it, but you'd probably need like an older computer or something weird like that to really do it. So I'm not going to worry about that for right now. We're going to break it in just a second, however. The big thing that we're going to do now is we need to get our renderer made. So you remember that I said that we have SDL that we have to initialize, which is done through our application class. Then we have to actually go through and create a window, which is now done through our window class. Then what we have to do is we actually have to create a renderer object for the window. And what that does is that basically is where we're going to draw our OpenGL to. So this OpenGL is basically this OpenGL is going to be drawn to the renderer, which is part of the window. Because of that, what I'm going to do is our window object, since again, this is a video game, we shouldn't be having anything other than a renderer in our window object. So as a result, what we're going to do is we're going to put our renderer in here. So what we need to do first is we need to come here and we need to do SDL renderer. SDL renderer. And we're actually going to go through and again, like I said, with the window, if this is successful, we need to do some other stuff. So the big thing we need to do now is we need to come here and we need to do this SDL renderer is equal to SDL create renderer. We need to tell it that it's going to be attached to this window. Then we need to give it an index, which since this is the first instance of that for this window and everything, it's going to be -1. We need to give it some flags. So what we need to do is do SDL renderer accelerated. Oops. And then we're going to OR that with one other property, which I should probably go through and show you guys real quick what exactly this is. So let me open this up in a new window and bring up the documentation for this method. And again, this link will also be posted in the description below the YouTube video. And if you want it in the chat, just post something, I'll post it in there. So the SDL renderer flags are going to be a few different things. You have software, accelerated, present vsync, and renderer target texture. So this is pretty straightforward, but it requires some understanding of what's going on. So the first thing is software renderer. Basically, there's two ways you can do stuff. You can either use the hardware to draw it like that, or you can do software rendering, which is a bit slower, but it's a little bit more compatible, a little bit more sturdy type thing because it's all done in software. And that's probably not 100% perfect description of it, but it's close enough that I'm not going to worry about anything else with the description of it. So basically in this case, I've got a nice graphics card. We're going to use SDL renderer accelerated because that's going to give us our best performance. The other thing we're going to do is present vsync, which is basically going to make sure that it's synchronized with whatever refresh rate your monitor is. This is very important for virtual reality games because your eyes are very sensitive to this. You want to make sure that everything's lining up properly with synchronization and make sure you're targeting the 90 frames per second and stuff. Target texture is going to be another thing we'll be going over later. We will sort of need this because of the fact that you need to render the view twice. So we're actually going to have two different views, one rendered for each eye. And that's going to be done by rendering it to textures and presenting the textures to the screen with some warping because of the lenses in the virtual reality headsets. We're not going to worry about that right now. We're just going to use accelerated and vsync. So what we're going to do is we're going to have that. We have our create renderer. We have accelerated for that and present vsync. So that goes through and that creates our renderer. Now what we want to do is we're going to want to come over here and then check for if this was successful. So again, SDL render equals null pointer. We're going to throw, and in this case, we don't want to throw a window exception because that's going to just kind of not tell us enough about it. So what we actually want to do is we want to create a renderer exception. What we're going to do is we're going to actually have this inherit from there. And actually, we don't want to do that because renderer exception. The reason we don't want to do that is because of the fact that our renderer exception would then be too similar to our window exception and could be caught wrong. I don't want to deal with that. It's a little bit of a headache. This is going to be basically the same effect. There's not really a whole lot of a difference. And this kind of keeps our application simpler. So we have this exception that we'll throw then. And again, we need to copy all of this into this method below. So rather than do that, we're actually going to clean up our code a little bit more by making a private void setup renderer, or init renderer. And what this method is going to do is this is going to create the renderer doing everything we've done so far. So we're going to do it. Window init renderer. And there is that. So now we can just do this init renderer, and that has the same effect. So this will go through and throw an exception, which now we need to come back over here to application.c++. Whoops, that should be, yeah, there we go. Had to bring that window into focus to get it to stop saying there was an error there. So now we're going to come here. Again, same thing, except now it's a renderer exception. And this is going to again be in window.c++, but it's actually going to be at line 30. So take that, 30, and there we go. So now, if we go through and we run this, it's not going to really look all that different. It's going to look mostly the same. And there we go. Now, the other big thing we're going to want to do for our windows when we create them is we have window.shown for right now is the only thing. We need to again go through it. We need to have it find that page that I had up before. So we need to make sure that this has a few things. We need to have it have shown. We need to have it have OpenGL. So we're going to go through and we're going to get it ORed with that. And then we also want to have it be we'll keep that for now. We won't worry about that. So the big thing with this is it's not really good to have all of these like that. So what we're actually going to do is we're going to come over here to our window, and we're going to define a variable that basically is going to be our parameters for this. So SDL window flags. And that's going to be our basic flags for everything. So if we come here, take that, and that's all our flags created, ready to go for that. So if we go through and we create this again. So this is our window all ready to go. And we can do other things. We can make it so that they could resize it as well. So we can add in this, and the easiest way to do that is just go over here, update our parameters, and if we go through and run this now, we can now resize the window as much as we want. Now you'll notice though that the window does not have all this nice, kind of gets this ugly look because of how the renderers are set up. And again, that's just because of how that all works. So we can go through and shrink it, and you'll see all sorts of nasty effects and stuff. So again, we're not going to worry about that too much now, but that's the basic window creation system. So to kind of show you those exceptions real quick, because I had mentioned that, we're going to come down to our renderer, and if we do something bad here, for example, we do, and actually we should also have these be in a variable as well, because again, that's going to be window flag. This is going to just make everything a lot more succinct when we're trying to update these later, if we do. We shouldn't really need to, but it's just going to make everything a little bit better. So there's that. Quick way to throw an exception with this, if we go ahead and we do this to like 55 or something, this will go ahead and throw an exception because that's not a valid render mode. So you can see right there, renderer error, line 30 in C++ in window.c++ couldn't find matching render driver. So if we go to line 30 in windows.c++, we'll see this. This is where our error is. Oops, line 30, window.c++. So we know that this is the line where the error is. That's about as accurate as we'd be able to get. In this case, you'd have to kind of know that this is an error caused by the flags. Again, C++ is a little tricky in that you have to really know what you do. Yes, somebody pointed out in the chat, vsync also is there to avoid tearing. That's one of the big things, is so that, how to explain this? Basically, when you're rendering an image, it is sent to your monitor once every certain amount of time. So let's say that your game takes 16 milliseconds to render. So every 16 milliseconds it sends a frame over. So your monitor might refresh faster or slower depending on how fast your monitor is. So if your monitor refreshes every 16 milliseconds on the dot, then when you have vsync off, what it will do is it will send it over and it'll match up, it's perfect. However, and this is important, if your monitor updates, let's say every 8 milliseconds, so rather than 16, what will end up happening is the monitor will say, hey, I'm ready for a frame, but your application is only halfway done rendering the scene. What will end up happening is it will say, okay, give me what you have so far and then start whatever's next. So it'll go through, it'll render half the scene, and the other half will be empty. That's what vsync is for. Vsync basically says, okay, I'm not ready to render the scene yet. I can't do that. So the monitor says, okay, when I come back around, you can give it to me then. So for that same section, it just displays what was there already. That's why you can actually see some slowdowns when you have vsync on, is that it's basically your monitor saying, hey, I'm ready for an update. Your game itself says, hey, I'm taking a little bit longer, just give me a sec, and then it renders it whenever it gets to it. For virtual reality, this is pretty important because, again, you want to make sure everything matches up perfectly so you don't have half your scene rendered one way and half another. But that's basically what is called tearing, as pointed out by Tueger? Not sure how to pronounce that name. But yeah, that's another reason for vertical sync, vsync. There's other things that go into play there that I'm not going to dive super into, but as pointed out, that is a very important one, is tearing. And again, you can turn that off optionally. Sometimes it won't break everything, but generally it's a good idea to keep it on. Anyways, continuing on. So that is our basic application for now. And again, this is all using the singleton pattern for the actual application itself. It's a very straightforward method. And we only have one instance of that application running. And then within our application, we go through, we create our window, we go through and run it, pulling for all the different events for the keyboard. And again, this is all going to change a little bit further down as we start getting into actually the game creation side of this. But for now, we're not going to worry about that too much. So that's today's tutorial. If there are any questions going on in the chat right now, feel free to ask them and I will address them as best as I can. But yeah, so that is the basic tutorial for everything. Yeah, so I'll give everybody a second to ask questions. This is really diving mainly into exceptions, and again, I'll post that link for all the different types of exceptions and such in the into the video description below. It's really useful to know these. It's very, very good for debugging and stuff. So other things that we can do with this, since we are have a little bit of time, since I took forever remembering singleton, and also for buying Girl Scout cookies, we are going to do, and let me find where I did that originally so I can make sure I'm doing this right. So the other one that we can do here, and I'm not sure if people remember what I said we can do key detection, is we can do key down. I had a break there, and this will handle our keys. So we could actually, when we get to doing game states and such later for all of this, we'll go into how do you pass these into it and stuff like that. But for now, what we can do is we can just go through and switch through and key symbols and symbol case SDL key escape. And again, this is going to do the same thing, which is stopping. So yeah, that will go ahead and make it so now if we run it, if we go ahead and we press the escape key, once it's all loaded, it will exit as expected. And this we'll go over more later. We'll go over some other event types as well. Really the big focus I wanted to go into is how do you create a window, how do you set it up for OpenGL, how do you organize it and structure it, kind of showing the singleton pattern and how useful that is for these applications. And just generally showing window creation and stuff. Now, of course, with this application, we could actually have more than one window. We need more than one window object, but I'm not really going to go over that now. The other thing you could do in theory is you could have 2 or more renderers. So to kind of dig deeper into that real quick before we end this, the renderer is needed because OpenGL just kind of draws things, but it needs a place to draw them to that gets displayed to the user. And so the way that OpenGL is broken up is to have the renderer receive all of the drawing, and then the renderer is really just, in basic terminology, again, do not take this to heart, but in a very simplistic idea, it's basically an image that gets displayed in the window. That's able to be updated dynamically, real time, and all that. But basically, OpenGL needs somewhere to put all of that. And again, you can create all of this without SDL. It's just a lot more code, it's a lot more time, and I felt like this is actually going to be a better way to approach this. So, yeah, that's the basic summary. Next time when we start going over this again, we're going to be focusing on a very simplistic game loop, and also talking a little bit about preparing for OpenGL. It might seem like I'm trying to avoid going into OpenGL, and I don't want to do that. However, I want to make sure that we have a good starting place to go. I don't want us to just start rendering stuff and drawing things to the screen and saying, hey, this looks cool. I want to really make sure you understand how to make a 3D OpenGL game. The focus of this is by the end of this, we'll have this really awesome virtual reality game, definitely with Oculus Rift support. Hopefully, if somehow it works out, I could get a Vive, and we could have Vive support. But definitely for the Rift support. And we want to make sure that this runs well. As you probably heard, I mentioned 90 frames per second. The Rift requires 90 frames per second. This is important. So we really need to make sure we have a good system down to do this. So I really want to make sure we have our game states figured out. We have how that's going to work. I want to make sure that we have input ready to go so we can kind of dive right in once we have the OpenGL working. So next time we're going to be going over the game state management system, and we're going to discuss a little bit about OpenGL rendering and some of the complex stuff that's going to go into that. There might be a little bit of multi-threading into this as well, just because that's important for making your application run smoothly. And how do you get the events tied in with that game state, and where does the rendering actually happen and such. So that's it for today's video. Hope you guys enjoyed this. I apologize again for totally blanking on the term singleton pattern. So next time we'll be going over more. For now, that is it for today. I hope you guys enjoyed this video. Apologize again for the length of it. It's a little more than an hour, which I didn't want to do. But yeah, it doesn't look like there's any questions. So if you have comments or questions on the video on YouTube, feel free to post them below, and I will do my best to answer them. Make sure you check out last week's video, and keep an eye out for next week's video. Again, 3 p.m. Eastern Time Standard, 12 p.m. Noon Pacific Time Standard, and 8 p.m. for the global GMT. yeah, thank you guys for tuning in. Hope you guys found this video helpful and useful. I hope that this all makes sense, and if you guys have questions, feel free to ask away. Yeah, see you guys next week.